here are our examples from our types of functions notes, calculator specific for the TI84. So we are starting with this example here, and our job, according to our directions, is to graph this function on its limited domain. Anytime you graph on your calculator, you should provide a sketch of what you see in your window. So this rectangle, right, will contain what I see on the window of my calculator. I also needed to provide any y-intercepts, any x-intercepts, any vertical asymptotes, and give the range. Okay. So we're already in our equation editor, y equals. I've cleared out any equations, and I'm going to enter this function x squared minus 6x plus 40. So I'm going to put in my x squared. We're going to subtract 6 times x, add 40. And on the TI84, to enter my limited domain, I'm going to go divided by and then an open parentheses. Remember that if 0 is less than or equal to x is less than or equal to 8, then that means x is greater than or equal to 0 and x is less than or equal to 8. So I have x. I need my test menu, second math, is less than or equal to, is greater than or equal to, so it's my fourth option, 0, and test logic. There's my and, x, back to my test menu, is less than or equal to my sixth option, and that would be an 8, close my parentheses. So now I'm going to graph. I always like to start with a zoom standard that takes me back to a negative 10 to 10 window, and what we see is nothing. So again, let's just think a little bit about this graph. We know that the graph of this quadratic is going to be a little happy parabola, and its y-intercept is going to be 40. So without a lot of analysis, somehow, some way, this parabola is going to pass through the y-axis at 40, and it's going to turn upwards. So on a negative 10 to 10 window, feasible that I am not high enough to capture that graph. So we're going to go into our window, and we're going to adjust. With the domain from 0 to 8, I want to go a little bit left of 0. Let's try negative 2 for my minimum. A little bit right of 8, 10 works. Scale of 1 is fine. For my x minimum, I don't probably, based on that I see nothing, don't need to go as low as negative 10, but I want to go somewhere around 40, so I'm going to try 30 for my minimum and 50 for my maximum. I'm going to go on a scale of 5 there, and let's just see what happens. I guessed on the y-min, y-max. I can always come back and change it. So when I hit graph, I see my parabola start at 0, but I don't see it end. Right? So that tells me I probably want to go higher, so I'm going to go back in my window, and let's change this 50 to 70 and graph again. So again, I see my parabola start, I see it stop. If I go trace, I traced the beginning of my domain, 0, and I'm at the point 0, 40. That is my y-intercept. So we know that our y-intercept is 40. If I trace to the end of my graph, right, so my domain stopped at 8, I reach the point 856. I'm looking for my x-intercept. If I come and I use my left arrow and I follow that, my x-intercept is going to occur when y is 0. So watching my x and y values at the bottom of the screen, right now I'm at y equals 35, right? That y value never, right, reaches 0. If I come back and I change my window so that my y minimum is, say, negative 10, so I can see where y is 0, and graph again, we can see that there are no x-intercepts, so there are none. There are also no vertical asymptotes here. Now, for my range, I want the lowest y and the highest y on my graph, right? We can see from our graph that the highest y is going to occur at our endpoint on the right side. So if we go back and trace to when x is 8 again, we can see y is 56. That is going to be the upper limit of my range. The lower limit of my range is at the vertex of this parabola. And I can trace and guess, but there's a better way provided by my calculator. I have this CALC in blue option, so if I go second trace, that's going to get me to my calculate menu. And one of my options is minimum. So I'm going to select that third option, and it asks me for left bound. That's telling me I want to move my cursor to the left of my minimum. So I'm going to go to the left until I'm definitely right above my minimum, press enter. It now asks for the right bound. I'm going to move to the right of my minimum, press enter. It offers a guess, press enter to accept the guess, and it tells me that my minimum occurs when x is 2.9999, y is 31. Just on the way the calculator works, that's probably at 3. If I go to trace to 3, you can see y is 31. So that's the minimum value of my y, and my range is from y to 56. If I sketch what's in my window, here is my y-axis, here is my x-axis, and what I see goes from here to about here. If I go back to my window, I can mark that my minimum x is -2, my max x is 10, my minimum y is -10, and my x max is 70. Right? Those should be included when you sketch a graph. Okay. Now, this function had no x-intercepts. Let's look at how to find them. I'm going to go to y equals, and I'm going to enter a new function. G of x is equal to -x squared minus 6x plus 40. On the same limited domain. So I'm just going to go in here and I'm going to insert, second delete will insert a negative in front of that x squared. And I'm going to go back and I'm going to do a zoom standard again, zoom 6. So the negative should flip my parabola over, right? So what I should see, what I anticipate seeing here is a parabola again with y-intercept 40, but this time being a sad parabola, and we're going from 0 to 8, right? So I'm not sure where that falls, but somehow, right, in this portion of the graph. So I can see that I've got an x-intercept, but I'd like to see more of that graph. So let's go back to our window, and let's go below 0, -2, above 8, 10 is fine. This time I'm looking for an x-intercept, that's when y is 0. So I'm going to, a -10 is good. I didn't see high enough. Let's go up above 40 to 50. Actually, we went up to, well, we'll try that on a scale of 5, and let's graph again. Okay, so better. It looks like to get to 8, I'm going to need to go lower, so let's try -50 and graph. We see our function start, and let's try lower again. Okay, so I'm just playing with this. You could do that too, so let's go to -70. One more time, let's go to -100. Start and stop, you can see that there is one x-intercept. So what I'm seeing here, here's my x, my y-axis, and my graph is going from here to here. And I am looking for this x-intercept. Okay, again, we could trace and guess, but our calculator gives us a better way in the calculate menu, so we're going to go second trace to calculate. This time, an x-intercept is also called a 0, so we're going to select 2, right? We're going to move left of that x-intercept. You'll notice y is greater than 0 here. Then we're going to move right of that x-intercept. Y is now negative. Press enter to accept the guess, and it tells us our 0 is when x is 4 and y is 0. So that tells me that this point is at the point 4, 0, and our x-intercept would be 4. So that second calculate menu is really helpful. Let's look at this second example. So I'm going to go back to y equals. I'm going to clear out this equation. And this time I'm going to enter the equation 25, right, divided by, just to be safe, I'm going to put my denominator in parentheses, and I have x squared. Divided by my domain, open parentheses, I want x, test, second math, is greater than 3, 0, close parentheses. I'm going to do a zoom standard, zoom 6, and my rectangle, and I have my x-axis, my y-axis, and what I see looks like this. I didn't adjust my window here because x is greater than 0, so I'm never going to be able to reach the end of that. So I'm looking for what begins right after 0, and I can see there. If I do extend my window, I might just go to, say, -1, so I'm going behind 0, and x max, let's try 100 on a scale of 10. My y-min, it doesn't look like it goes below the y-axis, so I'll try -2 again. And let's try 100 on a scale of 10. If I graph again, and it becomes hard to see because this graph is so close. So liking what we had here, so that was -10 to 10, -10 to 10. I'm going to go zoom standard again to get back to that window. Okay, I want a y-intercept, okay, and there is no y-intercept here, right, because x cannot equal 0 if x is greater than 0. I want an x-intercept here, right? There are none because this function never reaches the x-axis. I want a vertical asymptote, and there actually is a vertical asymptote. That vertical asymptote, right, that's my vertical asymptote, is the y-axis. That's the line x equals 0. And my range would not include 0, but would be anything above it. So that would be parentheses at 0. And, right, so approaching the x-axis, right, y equals 0. And then on the other end, it keeps going up and up. So that would be infinity. Okay. That's your example for the TI84.